All right, hello guys. So we're going to continue with a discussion about the chapter sets. And if you would like to review all these, the previous topics, all you need to do is to view the previous video so that we can have a discussion. You can guys have a review on that particular chapter or part. Now, today we're going to discuss about the universal set, complement set, and how to illustrate these sets in a Venn diagram. So a universal set is a set that has elements of all related sets without any repetition of the elements. And the symbol here is epsilon. Unfortunately, Jamboard does not provide that particular epsilon symbol. So you can just Google it and see how it would look like. So an example of listing a set of the universal set is just the same to writing or listing the elements of a regular set. It's just that it is indicated with an epsilon symbol, okay, to emphasize that this is a universal set. Now, when you're given a universal set, you are also given a different kinds of set that are said to be a part of that universal set, meaning to say the elements that you're going to have to that other sets being compared are also parts of the universal set. So let's say, for example, I have here a set A, and if you are going to notice, the elements of set A are also the elements of the universal set. So that is how you're going to analyze that. So there are, in other problems, you could encounter different kinds of sets aside from set A. It could be like set B, which is composed of even numbers. Set C is composed of odd numbers. Set D is composed of prime numbers, and so on and so forth. However, for this one, we're just going to stick with set A. The next thing that I would like to discuss to you is about the complement set. So when we say a complement set, this is the set that includes all the elements of the universal set that are not present in the given set. So in here, we have to understand that set A is composed of elements 1, 2, 3, 4, and 5. And if we are going to find the complement of A, or the A prime, so to speak, what we need to do is to find out the elements that are not present in set A, but visible in the universal set. So let's say, for example, if you're going to see that the numbers of A is from 1 to 5, and the ones that were not written were 6, 7, 8, 9, 10, then automatically the complement of A will be a set with elements 6, 7, 8, 9, and 10. Okay. So supposedly we added another set here. So let's say, for example, I have set B, which is 2, 4, 6, 8, and 10. So what I want you to do is to pause this video and try to answer the complement of B and see whether you will be able to get the correct answer. All right, so we know that the set B is composed of even numbers such as 2, 4, 6, 8, 10, which means that the complement of B will be the elements that are not visible in set B, but can be seen in the universal set. So meaning to say the elements are 1, 3, 5, 7, and 9. Okay, if you were able to get this one, then I congratulate you. You were able to find or to understand this particular part of the lesson. Okay, moving on to the next part. So illustration in the Venn diagram. So suppose that we are asked to illustrate the universal set and set A that we just had in a Venn diagram. Okay. Illustrating a universal set in a diagram, an event diagram, would mean that you are going to have a box. So this is normal when you are answering a Venn diagram wherein you have the box. However, in this one, it is indicated that this box pertains to the universal set. Okay, so imagine that the elements of the universal set are inside this box. So you will see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 inside this box. And since we know that A is part of the universal set, so that means that A would be here inside the box. And for us to illustrate a regular set, what we need to do is to make a circle. Circle is being used to illustrate a regular set and adding it with the name to indicate that this particular circle are a set which contains the elements of which contains inside the universal set. All right. So now we're going to be going to write down the elements inside. So in my case, what I usually do here is I start with the smallest number of elements, which is set A, because all I need to do is to just write it down. And as you notice, there are some elements in the universal set that were not written in here yet, which means that these elements are said to be written outside the circle because these numbers are not included in set A. So in here, guys, you will now be able to visually see what these elements are that are outside the particular set of A, which also indicates that these elements are said to be the elements of the complement of set A. So if you're going to write it down, so that would mean that your A prime will be equivalent to 6, 7, 8, 9, and 10. Okay. All right. So it says here, describe the set A in words and in set notation. So if you're going to write it down, this is going to be the complement of A or A prime are positive integers from 6 to 10 inclusive. Or if you're going to describe it in set in set notation, so this is going to be A prime is equivalent to X, such that X is an integer from 6 to 10 inclusive. All right. So now we are going to the next part, which involves proper subsets and illustrating proper subsets in a Venn diagram. The first thing that I would like to discuss is the symbol of the subset, which has this a U form. However, it's facing the right. This means that this is a proper subset. So we can say that this thing is a proper subset of that thing, or that thing is a proper set of the other one, something like that. All right. So in this case, in this case, what you need to understand is that a proper subset, okay, is a set wherein the elements are included in the given set, okay, or included in another set. So notice that set A is a set with elements 1, 2, 3, 4, 5. So that means just like what we did a while ago, we are going to illustrate a set in a circle, with a circle, with the title indicating on the side. And we are going to imagine that this set includes all these elements 1, 2, 3, 4, 5. And as we can see, set B here, if you are going to pay attention in the set B, the elements of the set B are said to be seen in the elements of set A. So if I'm going to write set B, then I could automatically say that this set B will be a set that is inside the set A. So meaning to say, if I'm going to write it down, the elements of the set B are 1, 2, 3. And as you can see, it is also inside set A, then that means it's also part of set A. However, there are some elements that are not found in set B that could be found in set A. Okay, so those are 5 and 4. Okay, so in this case, we can now say that B is a proper subset of A. All right. Okay, so the question here is, why is the diagram not inside the box? Some of you might be thinking, like, why did Mr. Ronald did not put a box here instead of putting a box to what we had a while ago? Okay, so the answer lies in here. We only use a box if we have a universal set. So meaning to say, if you are going to illustrate a universal set, then that is the only time that you're going to use a box. So that's the difference between writing a set and writing a universal set, or illustrating a set versus illustrating a universal set. So universal set uses box, a set only uses a circle. All right. And in this case, since we are not comparing these values or these sets to the universal set, then we can say that it will not be possible for us to get a complement for these two sets. So we cannot say that, okay, find the complement of A or find the complement of B, because complement means we are comparing it to the universal set. All right. Okay, so in this part, we are going to list and illustrate a proper subset of a set. So like what I said to you guys, if we are going to list down the proper subset of a set, what we need to understand is the number of elements of the set, okay, is 2, which means that the number of the elements of a subset, okay, let's say for example, of a subset should not be greater than 2. Okay, cannot be greater than 2. Then 2. So that means the elements that you will have in your subset should only be 1. So let's say, for example, if set A got elements of 1 and 2, then that means a proper subset of A can be equivalent to 1, or it can also be equivalent to 2. Or other than that, it could have an element that is said to be an empty set. Okay, so empty set, it will always be an element or a proper subset of any given set. Okay, so from here, let's say for example, if we are going to illustrate these sets, so like I said, we do not use boxes. So let's say for example, if we are going to illustrate the elements wherein the subset is 1, then that means the 1 should be inside the smaller box, so smaller circle, and the 2 will be put outside. So this one refers to this one. Okay, now if we are going to rewrite, or if we are going to illustrate this set, this would mean that we're going to be having 2 circles again. And this is set A. And we say that 2 is the proper subset of A. So that means, okay, 2 should be inside the circle and 1 should be outside. Or it could also be possible that the elements of the set is a null set, meaning the circle inside the circle will be empty, and thus the elements 1 and 2 will be outside. Okay, so we have to understand here that the subset cannot have elements that are equal or greater than the given set. So it should only be less than the given set. All right, so let's try to see whether you guys fully understand this particular problem. So all you need to do is to pause this video and try to answer and list down the proper subsets of B. Okay, so I hope you guys were able to list down the proper subsets of B. So in this case, we have to understand that if we are pertaining to the number of elements, since the total elements of B is equivalent to 3, then that means the elements of the subsets should have 2 or less. Okay, so if I'm going to write it down, so I will be choosing elements with a total of 2. So it could be AB, a combination of AB, or a combination of AC, or a combination of BC. So in here, you will now see that there are 3 elements, 3 sets with 3 proper subsets with 2 given elements. And after that, we are going to list down the subsets whose elements is equivalent to 1. So you have A, you can also have B, and you can also have C in there. And again, just like what we say, a null set is a proper subset of a given set. So that means you should have a null set or as part of the answer. Okay, I hope you guys were able to get this one. All right, so that will be it. Our next meeting will be discussing about the union and intersection of sets, and at the same time, the shading of the given sets. So we are also going to discuss combining or combination of sets and solving these particular problems. All right, please don't forget to follow and subscribe, and you can share it to your classmates or to any of your friends who are in the same level with you. Okay, goodbye, guys.